In 11th question, feedback rating, smoothing and outlier detection. Consider the feedback rating same as question in 2. Part A. Smooth the rating using bin, mean with bin depth. Third, illustrate the steps. Solution for data. Bin depth and step 1. Organize data in ascending order. Let's organize the data. Is already sorted in total values 12. Create bin n of depth 3. Number of bins 12 plus 3 is 4 bins. Bins. You can see in this table. Third step is replace original value with bin values. Original values are given in there and smoothing data bin values mean are considering in this. And interpretation of this bin mean smoothing reducing noise and create a simple distribution with a 4 distinct range making patterns easier to identify. Section B, part B out there. Suggestion way to detect outliers. Solution of this question. Outliers are extremely values significantly different from typical data points. First static method z square, the formula you have seen, where x is individual value, is mean value, and sigma is standard deviation. And decision rules are modulus z is greater than 3 is extremely outlier. And when the modulus z is greater than 2 is moderate outlier. Calculating example mean for value 5 and for value 215. Advantage of this is standardization and mathematically rigidity, and disadvantage of assumption normal distribution sensitive to extreme values. And second is IQR method interquartile range. Steps. First, calculate Q1 and second QR1 equals to Q3 minus question 1. Lower fence Q1 minus 1.5 into IQR and upper fence is Q3 plus 1.5 into IQR. Value outsider fence are outliers. Example on this Q1 is 92, QR is 81, lower fence is 110.5 and upper fence is 213.5 and outlier detection is 215 exceed upper fence. Advantage of this reboost the extreme values and disadvantage is arbitrary threshold may missing subtitle outliers. And visual method third is box plot and histograph. Box plot visualize medians, quartiles, and fringe and outliers. Point beyond the whiskers represent outliers and after useful for comparing multiple feedback categories. Histograph shows the d- distribution shape, identifiers isolated frequency, and reveals by model distribution, e.g., satisfying versus dissatisfying cluster. Advantage of this intuitive and easy communication. Disadvantage subjective interpretation. 4. Domain specific method for feedback data. Abnormally high satisfying. Rating is greater than 19th percentile, while other rating are normal. Perfect 5 and 5 score across all questions, unrealistic consistency. Third is potential cause. Faculty's members peer infrared self-rating, abnormal low satisfaction. In this, rating is greater than 10, is not greater than 10. In this is minimum than 10 percentile. 5 upon 1 upon 5 score across all the question, extreme dissatisfying. Potential cause, student grievance, technical issue bias. Detection approach, cluster feedback rating by faculty's member and course. Identity rating exit normal cluster range. And third one is cross reference with the eh, respond meta for patterns. Part C discussing other method for data smoothing. Solution moving average. Moving description of this and replace each value with the average of itself and neighbor values. Formula is S1. S1 with the example of the subset S2, S3 and S4. Yes. And window size is 3. Advantage is reducing noise and preserve local trends. And disadvantage of this is loss boundaries values and computationally expensive. Second is exponential smoothing. Description apply weight average with the more weight to relevant values. Formula of ST equals to AX1 plus 1 minus alpha into XT minus 1, where 0 is lower than alpha and is smaller than 1 is by smoothing parameters. Advanced capture trends adopted to change required parameters turning sensitive to a alpha value. Regression smoothing in third part. Description fill poly um, polynomials or regression model and use predictive values. Approach fit curves, replace original values with the model predictor, and reduce random noise while pursuing system patterns. Advantage of this is capture underlying trend theoretical sound. Disadvantage may over smooth or under smooth. Kernel density estimation. Fourth one, estimating underlying probability distribution using kernel function. The advantage of this is non-parametric smooth and density estimate. And disadvantage complex requires bandwidth and selective. And fifth one is lowless and local weight stepper plots and smoothing. Description combines local regression with the smooth with in small neighborhoods. Advantage flexible captured local patterns. Disadvantage computation in, intensive. Sixth is smooth splits and description use piecewise polynomial function displaying the connected knots. An advantage high flexible, smooth curves, and disadvantage risk of overfitting. Next, move on to the 12th question. 12th question is data integration from MCA and MTech analytics. Discussing scheme integration handling, remoundation data, e.g. duplicate entries from multiple survey, and resolving conflict in values. Solution of this is scheme integration. Definition process of combination data from multiple source with different structure into an unified scheme. Challenges naming heterogeneity, type heterogeneity, and structural heterogeneity. Resolving approach. You you are clearly see in this table by the example of source 1, source 2, and unified scheme. Second, handling rebounded data, duplicate detection, exact duplication, and approximately and fuzzy duplicates, same faculty, similar but not identical rating. Second one is typos name and same feedbacks. Resolution technique. A. Deduplication and keep one record, keep earliest time stepped, keep higher quality complete record, use voting if multiple partition of records. B. Aggregation, average duplicate rating, keep maximum and minimum values, merge attributes. The C is record linkage, use probabilistic machine matching, compare on multiple field, name ID depth, calculating matching score, and flag records above threshold for reviewing. Example are there. 3. Resolving conflicts in value. Conflicts type 1, contradictory value, same faculties, rate 5 on 5 in survey, but 2 on 5 in survey B. Resolution. The steps of this investigate source, time stepped based, and weighted average and keep both. Conflict type 2, inconsistent data. Resolution and conflict type, missing versus present data, and something special and This is called resolution. Use non-null values, fill in the blanks with available data. If conflicts, prefer primary source, predefined priority, document source for audit trails, conflict type, format, inconsistency in this data and phone number, resolution, and standardized format like iOS, and parse and convert all variants very written after conversion. Start with the question number 13, normalization method. Discuss normalization method. Solution. Start with the min-max normalization. Scale value to fixed range 0, comma 1 using minimum and maximum. Formula is x normal is equal to x minus x mean upon x max minus x mean. Steps: find minimum and maximum value in dataset. Second one is subtract minimum from each value. Divide by range maximum to minimum. Example with feedback, rating 5, comma 10, and so on. And x mean equals to 5, comma x max. And range is 215 minus 5 equals to 210. You can see in this table. Advantage: produce value in 0, comma 1 range. Preserve a relationship between values. Intuition and easy to implement. Disadvantage: sensitive to extreme outliers, require non max and mean values, not suitable when new data may exit or originally range. Use cases: neutral network when you know absolute boundaries of data, comparing different attributes on the same scale. Z score normalization, standard data to mean 0 and standard deviation 1. Formula: x normal equals to x minus mu or standard deviation, where you know mu is mean and sigma is standard deviation. Steps: calculate mean, calculate standard deviation, subtract mean and divide by standard deviation for each value. Calculation the data. First step: calculate mean. Our mean is approximately 64.75. And second step: calculate standard deviation. The standard deviation is approximately 82.59. Move on to the third step: normalization sample values given in this table. Advantage: distribution awareness, considering speed of data. Handle outlier better than minimum maximum. Centers data at 0. Values typically in minus 3, comma 3 range. And no fixed range. Values can be exit to minus 3 to minus plus 3. Assume approximately normal distribution values. Rebounded theoretically can be values. Requires non-population mean standard deviation. Use cases. Use cases like statistical analysis and hypothesis test. Machine learning algorithms and sensitive to feature scaling. When data follows normal distribution, principal components analysis. And C, Z score normalization using mean absolute deviation. Mean absolute deviation then reviews to the version of Z square using median and med instead of mean deviation. X normal equals to x minus median upon mean absolute deviation, where median is middle value of the percentile. Steps: find median of dataset, calculate deviation from median, find median of absolute deviation, and divides them. For the example of calculating data, find median, sorted them, and find median. Calculate absolute deviation from median and sorted them. Find MAD. MAD means mean absolute deviation equals to, we have, after calculating all the values, we have find 22.5. And and the fourth step, By using this chart of table, we can find the med z score. So the advantage of this is robust to outliers, use median not mean, better for tweaking distribution, handle extreme values well. Disadvantage less commonly used, harder to interpret than standard z square, dependent on data genuinely. Use cases data with the extreme outliers, no normal distribution, when outlier reboosted in critical. Quality control and feedback analysis. Move on to the D. Decimal scaling. Definition normalization by dividing by power 10 to scale -1 to 1 or 0 to 1. Formula in this, where k is number of digits maximum absolute values. Steps of this, find maximum absolute value max x module. Determine k number of digits in k module and divide all the values with 10 to power k. Example calculation data have given and step first maximum absolute value. Maximum absolute value is 215 and the second step determining the k. After determining the k, it, it has 3 digits and k equals to 3. So the power of 10 is 1000. Third, scaling. Scaling by this normalized data with this table in the values of original with advantage, simple and intuitive, preserve a relation exactly, easy to implement, produce interpretable values. Disadvantage, arbitrary choice of k, different k values for different attributes, may proceed values is less than if one is max is large. Use case, quick exploratory analysis when decimal represent is meaningful. Data with known range. And last is when simplicity matters over statistical optimality. You can see in this chart and table. Let's move on to the question number 14. Normalization faculty workload values. Hmm. Question number 14 says normalize the following faculties workload value or per semester 200, 300, 400, 600 and 1000 using A and B. Solution of this given data. Maximum minimum normalization formula x normal equals to x minus x mean upon x max and x mean, and parameters x mean equals to 200 and x max is equals to 1000. The range is equals to 800. By the calculation of this. In this, we have find the normalized point values. Second one is Z score normalization. You know the formula, calculating the mean after fitting with the range of their and divided by 5 equals to the answer is 500 hours. Calculating standard deviation values in this table, sigma equals to 316.23 after the calculation. Calculated the Z score with the help of this table. Normalization using MET. MED equals to and normalization x minus median upon MED. Find the median for data this. The n is equals to 5 is an odd number. Median third value equals to 400 hours. Calculating absolute deviation and make a table by this. Find a median of absolute deviation. Sorted deviation 0, 100, 200, 200, 600. Made third value median is 200. Calculating the mean absolute deviation by the help of this table. Table made in this table. Decimal scaling formula x normal equals to x upon 10k and find the maximum value max module x equals to 1000 and determining k by this and scaling all the values with the help of this table. The table shows all the values in the as per the data. Let's move on to the 15th question. Normalizing feedback rating value 35 and it says 15th question using the feedback rating data sets normalization the value 35 using A mean and max normalization 0 to 1 B Z score normalization while the standard deviation is 12.94 and C decimal scaling and D discuss which method is most appropriate and why. Discussing the solution of feedback rating by the data. Target values is 35 and given standard deviation is 12.94. Mean and maximum normalization 0 to 1 range. By this formula, x equals to 35, the value of normalized. The mean value is 5 and max value is 251. So the range of this is 210. Calculating them. After calculating, the result normalized value is 0.143 and the interpretation of this rating 35 is the 40.30% along the scale from the minimum 0 to 1. B. Z score normalization. After applying the formula, we have the calculation of and the answer is 2.300. After normalization value is in the minus order. Interpretation rating 35 is 2.3 standard deviation below the meaning. This indicates below average satisfaction. Decimal scaling. C. Find maximum absolute equals to 215 and determining k. After determining k, put the power of 10 by k equals to the answer of this is 1000 and calculate the x normal 35 upon 1000. So the answer will be 0.35. An interpretation rating 35 is scaled to 0.035 on a decimal scale. B. Which method is most appropriate to discuss? Analysis of each method. Mean and max normalization 0.143. Pros. Preserve relative position in range 0, 1. Interpretable, suiting for machine learning. Cons. Highly sensitive outliers are there and distorts perception of typical rating. When appropriate, for bounded features, neutral networks, and when mean and max are meaningful limits. Z score normalization. Pros show position related to average and split identifier outlier when Z module is greater than 2 is usually distribution and awareness. Cause assumption normal distribution and value depends on mean standard deviation calculation and accuracy of this given data. When appropriate, statistically analysis hypothesis test and when the data approximately normal. Decimal 0.035 from simple determinism and preserve relationship cons produce very small value, no statistical interpretation, subjective k select when appropriate, quick analysis when simplicity is paramount, recommended for feedback rating analysis ZX. The justification of there is statistical relevance. Statistical relevance in feedback analysis often involve comparing satisfaction across multiple occurrence or courses. Z score directly indicates how far rating diverges from typically mean satisfaction. Third one is easy to identify below average. Second, outlier handling. Rating 35 as Z equals to minus 2 Point 3 correctly identified it usually low satisfaction. This alerts analysts to investigate potential issue. Minimum and maximum threats 35 as merely 14% along scale missing in insights. Third one is compatibility. Compatibility checking by Z score allowing meaning comparison across different feedback dimension. Is it technical quality versus course organization? Mean and max only works within the single attribute. Machine learning read lines. Many algorithms clustering regression assuming zero mean until variation, and Z score provides a natural interpret for fifth is interpretability for stakeholders. 2.3 standard deviation below average is more actionable than 0.143 on zero point 0.1 scale. Support decision making, easy identify faculties with